We take the patient medical records like doctor visits, hospital visits, medical procedures, prescription, diagnosis, and connect them like graph based upon the time they happen. This gives us a patient journey graph that can be analyzed pretty quickly to see patterns of good and bad outcomes and what path was most prevalent during those outcomes. This computational power of graph allows us quickly to view the aggregation of patient journeys without losing any of the individual details.
Medical records data has typically been stored in relational databases, and so analyzing and aggregating it has usually been a relational database problem. There are a couple of troubles with this historically. One is that it requires a lot of specialized knowledge to know how to query and present this information. Two is that it's often time-consuming and expensive in resources to do so. It requires a lot of heavy joins and typically batch processes. What we wanted with the patient journey was to be able to present this information dynamically to the user. So with just a couple of mouse clicks, a user can see across a population of patients what the treatment patterns are given particular criteria.
Neo4j is the established leader in graph technology, so it gives us Cypher, a simple declarative query language, and also the ability to add custom plugins for doing complicated traversals and graph algorithms. With these approaches, we are able to analyze million patients, about 100 million nodes, and a billion relationships almost instantaneously and provide results.
So there were two really exciting points in the sort of journey of the patient journey project. The first was when we started to look at patient journeys visually instead of as just rows of data in an Excel table, to see the events of the patient journey represented sequentially, visually. And this allowed us and our customers to see individual patients' health start to improve over time and what the individual steps were that were being taken to allow this to happen. The second exciting part, which is even more exciting, was to see how, using graph technology, we were able to very quickly aggregate these individual patient journeys and look at patterns of treatment across very large populations, up into the millions of patients.
We really love the vibrant and supportive user community. The ability to start a quick POC using Cypher and moving to advanced analytics using custom plugins. The whole process was smooth and supported by knowledgeable people from Neo4j. There is also tons of information available on blogs and Neo4j YouTube channel that helped us a lot.
So currently there are a number of customer projects that are doing implementations of patient journey model to look at various treatment problems. So I think a big part of this project moving forward is going to be enhancements that we add in support of those projects. Should also mention that patient journey is being taken up as part of the Neo4j support framework. I think one particularly interesting area of exploration would be to use graph algorithms and machine learning technology to start to identify patients that are similar to one another based on having similar journeys. Once we do this, we can start to look at communities of patients, communities of similar patients, and we can use this community information to start to drive predictive analytics. We can look at, treatment patterns that are effective for some within a community, and we can predict that they'll be effective for other members of the community.
The journey concept is a powerful paradigm and can be applied to a number of business verticals beside healthcare. For example, by capturing shopper behavior, click streams, purchases, page views. Retailers can analyze customer interest or the effectiveness of marketing strategies. We see more problems that don't fit well into the boxes of tables and indexes, but are better understood as chains of connection of events. Graph databases offer the ideal technology to address these sorts of problems.